Good afternoon to everyone. So today I am going to discuss about the architecture of 8085 microprocessor. So this is the architecture of 8085 microprocessor. So it consists of register selection, instruction register, instruction decoder and machine language, then arithmetic and logic units, flag, flip-flops, temporal register, accumulator, then timing and control circuits. So it consists of a status signal, DMA, reset, clock generation, then we have a serial I/O control. Serial I/O control, we have a SID line and SOD, serial input data, serial output data. Then we have a interrupt controller. We have a different types of interrupt controller, that is a INTR, INTA, interrupt request, interrupt acknowledgement. The interrupt acknowledgement is a low signal, then RST 5.5, 6.5, 7.5 trap. Then we have a register select. We have consist of a temporal register, that is called as an 8-bit. Then Z register, B register is also 8-bit, C register 8-bit, then D register, E register, H register, L register. Then we have a stack pointer, program counter, then increment or decrement address latch, then address buffer, it is also an 8-bit, then data under address buffer. So these are the architecture diagram of 8085, internal architecture diagram of 8085. The internal architecture of 8085 determines how and what operation it can be performed with the data operations, or store the 8-bit data, then perform the arithmetic and logical operations, test for conditions, sequence of execution of instruction, store the data temporarily, it read write memory called as a stack. So the next architecture parts concern the register. We have a 8085 has 6 general purpose register. It stores the 8-bit data during the program execution. So these 6 registers are identified as BC, DE, HL. So if we are using with that combination of BC, DE and HL, so it perform these some 16-bit operations. Then these registers are programmable. It can use to load the transfer the data from the register by using the instruction. So next is the accumulator. So accumulator is an 8-bit register, that is the part of an ALU. It is used to store the 8-bit data and to perform the ALU operation. The result of an operation is stored in the accumulator. The accumulator is defined as a register. The data on which operation is to be performed is operand. Some of the operands must be an accumulator. So the next component is program counter. The program counter is a 16-bit register. It deals with sequence of execution of instruction. So this register is a memory pointer. So the memory location, you have the 16-bit address. The microprocessor use this register to sequence the execution of the instruction. The function of the program counter is to point the memory address from which the next byte to be fetched. So then next component is the stack pointer. The stack pointer is also a 16-bit register. It used as a memory pointer. It points to a memory locations in read-write memory. So also it's called as a stack. The beginning of the stack is defined by loading the 16-bit address in the stack pointer. Then this unit synchronizes all the microprocessor operations with the clock and generates the control signal for necessary communication between the microprocessor and the peripheral devices. The control signal are similar to synchronization pulse is an oscilloscope. The read RD, it represents the read active low signal, and WR represents the write signal, or synchronization pulse indicating the availability of the data on the data bus. So these are the timing and control units components. So next one is the instruction register and decoder. The instruction register and decoder are part of the ALU. When an instruction is fetched from a memory, it is loaded into an instruction register. The decoder decodes the instruction and establishes the sequence of the events to be followed. The instruction register is not programmable and cannot be accessed by any instruction. Then next it will be a register array. So register array consists of, already discussed with the 2 additional registers are called temporal register W and Z, which are included in the register array along with the programmable register, namely BC, DE, HL and stack pointer and program counter. So these registers are used to hold 8-bit data during the execution of instruction. However, they are used to internally by microprocessor. They are available to the program. The next component is a multiplexer and demux units. This unit is used to select the register out of all the available register. This unit behaves as a multiplexer. When data is going from the register to an internal data bus, it behaves as a demux when the data is coming to a register from the internal data bus of the processor. The register select will behave the function based on the function of either mux or a demux. So the next component, it will be an address buffer. So this is an 8-bit unidirectional buffer. It used to drive the external high order address bus, that is A15 to A8. It is also used to tri-state high order address bus under the certain conditions such as reset, hold, halt, and when address is or not in use. So these are the components it can be used for the as an architecture of 8085 microprocessor. Then it will be an address and data buffer. This is an 8-bit bidirectional buffer. So it can be driven multiplexed address and data bus A0 to A7 or D0 to D7. So it is also used for tri-state multiplexed address data bus under the certain conditions such as reset, hold, halt when the bus is not in use. So these are the main components in the architecture of 8085 microprocessor. Thank you to all.